We're going to start in a while, okay?
Okay, thank you.
Okay, thank you.
Am I audible, sir?
Yes. Yeah, am I audible to all of you?
Absolutely, sir. Loud and clear.
Yes, sir. Welcome, sir. It is a matter of great pleasure for me to invite you, sir, in conference ICGETI 2025. Professor Dr. Sambit Kumar Parida, Director, Amity Institute of Pharmacy. Welcome again, sir. And now hand over to you, sir. The first technical session of the conference AI 2025.
Good afternoon to everyone. I'm Professor Sambit Kumar Parida. First of all, good afternoon to all the distinguished guests, esteemed colleagues, industry experts, and all those dear participants who are online mode. It gives me immense pleasure to welcome all of you to this exciting session on artificial intelligence and advanced information architecture 2025. This theme is not only timely but also transformative, as it represents the convergence of two of the most powerful forces shaping our digital future. Artificial intelligence, as all of you know, has moved far beyond being just a research curiosity. It is now embedded to our daily lives, from personalized healthcare and smart cities to financial systems and educations. At the same time, none of these advancements are possible without robust information architecture, the framework, the system, and structure that allows data to flow seamlessly, securely, and meaningfully. Together, AI and information architectures, we all know that are very redefining the way we think, work, and innovate. What makes this field more fascinating is its interdisciplinarity. It is not just about algorithms or databases, it is about creating ecosystem where humans and machines collaborate to generate insights, make decisions, and solve problems that were once thought unsolvable. Whether it is through responsible AI for social goods, next generation data managements for sustainable industries, or advanced architectures for high performance computing. The scope is vast and promising. But with this promise comes responsibility. As we adopt AI-driven architecture, we must remain mindful of ethics, transparency, and inclusiveness. The system we design today will save the trust, security, and fairness of tomorrow's digital society. This conference brings together brilliant minds from academia, industry, research institutions. I encourage all of you to share your ideas openly, challenge assumptions, explore collaborations together. We can contribute not only to technological progresses, but also a future where AI and information architecture empowers humanity more meaningful manner and responsible ways. On that note, I am having the privilege to introduce all of you the speaker who is the limelight for today, Professor Vasilis C. Gerogiannis. With your due permissions, let me tell something about you. Professor and Head of Department of Digital System, University of Thessaly, Greece. Dr. Gerogiannis holds a diploma in computer engineering and informatics, as well as a PhD in software engineering from University of Patras, Greece. He is full-time professor in the Department of Digital Systems of the School of Technology at the University of Thessaly, Greece. In the recent past, he was a full-time professor in the Department of Business Administrations at the Technological Education Institutes of Thessaly, Greece from 2004. He is also adjunct professor teaching software engineering at the Hellenic Open University and modular leader at teaching software projects management at post-graduation programs of studies offered by the University of Thessaly. He is visiting professors at foreign higher education institutes and universities, among them at the IPAG Business School, Paris and Nice, France, and at the American University of Beirut, Lebanon. From 1992 until present, Professor Gerogiannis has participated as technical consultant, software engineer, project manager, and research director in several R&D projects funded by European Union or national organizations. He has authored or co-authored more than 130 papers published in international journals, conference proceedings, which have been cited in the plethora of citations, as well as he has co-authored the edited 3 scientific books. He acts as guest editor, member of the editorial board, and reviewer in the international journals. He serves as program chair, member of the organization technical committee, and invited speakers in international conferences. He has also received the Best Paper Award in 2 international conferences. His current research interests include software engineering, project management, and decision making. At present, Professor Gerogiannis serves as member of the management board of Hellenic National Academic Recognition Information Center, NARIC, member of the Regional Council for Research and Innovations in the region of Thessaly,
Thank you very much. Thank you very much, Professor Submit, for this very esteemed introduction and invitation. Good day, ladies and gentlemen. My name is Vasilis Gerogiannis. Can I share my screen?
Yeah.
Can you see the slides of my presentation?
Absolutely, sir. Clearly.
Thank you very much. So I'm a professor and chair of the Department of Digital Systems at the University of Thessaly in Greece. It is a great pleasure for me and also a great honor to present the speech to the 5th International Convention on Green Environment, Technology and Entrepreneurship through Innovation. I would like to express my deep gratitude to the organizing committee of the conference for their esteemed invitation. Today's presentation is about the transformative role, as Professor Submit mentioned before, of AI, and in particular of generative AI, in the field of content creation. We will explore together the core applications of this technology and how this technology is changing industries and what this means for creators, for businesses, and in general for our society. But before, just a moment, before proceeding to my technical presentation, I would like to briefly present my university. It is the University of Thessaly in Greece. It is a public university. It is located in the historically rich and picturesque region of Thessaly in central Greece. You know, Greece, as India, are two countries which are full of history, civilization, culture, and they are beautiful countries. And I will be very happy next time to have the opportunity to visit your university and your beautiful country on site next time. So my university consists of 35 departments and 8 schools. It is a big university. It is the 3rd largest public university in Greece. It was established in 1984. We have more than 45,000 students, and we offer a wide range of undergraduate and postgraduate programs. My university is a distributed university since it is located into 5 different cities all over the central part of Greece, the central region of Greece, the name of which is Thessaly. And the core mission of my university is the advancement of scientific knowledge and, of course, research. And our contribution focuses on the cultural and economic development of both local and global communities. We are very proud for our international reputation for excellence in research and innovation, and our university is recognized worldwide for its outstanding scientific experiments. Now I will start my technical presentation. Let me walk with you through the agenda of my presentation. I will begin by explaining what generative AI is and how it differs from traditional AI. Next, I will examine the paradigm shift this technology is causing in creative industries. And I will also explain some key benefits of using this technology. Then I will explore some real-world applications. And one characteristic example is the Self-Tail platform. And we will present, of course, the future possibilities, including some very important ethical challenges. And finally, I will conclude with a vision, let's say, for what lies in the future, what lies ahead. And I will be happy to take your questions. So what is generative AI? Generative AI is a branch of artificial intelligence that is focused on creating content. Unlike older AI that mainly analyze data, generative models can produce entirely new content, like new text, images, video, music, 3D objects, and several types of content. These technologies are powered by large pre-trained models capable of producing human life results from very simple inputs. And generative AI technologies are already reshaping creative professions, from copywriting and illustration to product design. The AI landscape has rapidly expanded in our recent days. Text-based models like ChatGPT and Gemini assist with writing, planning, and analysis. We have also text-to-video systems like Sora and Veo, which create visual content from natural language. There are also other tools which integrate into complex workflows, like digital twins for simulations, or LangChain for building AI-powered applications. And all these tools together work together can collaborate to create a flexible and dynamic ecosystem for both creators and businesses. And they are actually performing a revolution today in content development and all related businesses. So we are seeing today a major shift from a major shift in how products are designed and produced and manufactured. Generative AI enables the so-called intelligent customization. And what is the meaning of intelligent customization? We have users who describe what they want, and AI helps to design it. And this lowers barriers and somehow decentralizes manufacturing and production, thus allowing more people to create unique products. from personalized medical devices to one-of-a-kind sneakers, we are moving from mass production to the so-called mass personalization. Historically, customization was limited to rule-based systems in the early 2000s, where we have manual inputs and rigid options. In 2010, there were parametric design made things more complex and, of course, more flexible, but still required technical know-how. And this is why these technologies were a little bit complex. Now, with generative AI, and of course with cloud computing, anyone can create custom designs instantly and, of course, at a scale with much less effort. In this transparency, you may see the so-called personalization spectrum. Customization today exists on a spectrum. On one hand, at the left, we have static templates with very little flexibility. In the middle of this spectrum, there are the so-called rule-based systems with limited logic and, of course, capabilities. And on the other end, at the right part, we have generative customization, which offers real-time AI-driven designs that respond to individual preferences. And this shift is already visible in various industries, such as fashion, wellness, and digital art. Generative AI adds value across the entire product lifecycle. It helps to spot trends and generate ideas in the early design stages. It can also convert descriptions into realistic images, or also to convert descriptions and designs into product visuals. It also supports virtual prototyping to create mockups, marketing automation, and even post-launch feedback loops through sentiment analysis. So AI role is a fork circle tool that substantially improves efficiency and creativity in product design. I will explain to you my perspective on these technologies, and my perspective is the so-called democratizing design. What is the meaning of this? In the past, professional design required years of training and expensive design tools, and of course expensive software. And today, with the AI, almost anyone of us can create high quality designs using simply natural language. And this is a kind of democratization which opens opportunities for small businesses, educators, freelancers, and non-technical creatives. This kind of democratization, democracy is a Greek word. Actually, democracy was invented in ancient Athens, in ancient Greece. And in terms of generative AI, generative AI brings democratization because it is a powerful shift into who gets to participate in the creative, into who gets to participate in the creative production and economy. The next wave of generative customization includes multimodal input, combining voice, sketches, photos, videos, and text. And all systems are helping to manage adaptive supply chains that can respond to real-time needs. And with by using hyperlocal trend analysis, products can be tailored to cultural or regional preferences. Ethical personalization is also gaining ground, factoring in user values like privacy and sustainability. The best results happen, of course, when humans and AI collaborate together. On one hand, people bring vision, context, and intent. On the other hand, AI brings speed, scale, and creative variation. Together, users and AI can create outcomes that are personalized, innovative, and often unexpected. Rather than replace designers, AI becomes a kind of co-pilot in the creative process. As an example of this creativity, I will present to you the Self-Tail platform. Actually, at the intersection of creativity and AI platforms, we have many types of these platforms. Self-Tail is one example platform that has been developed by a team of my students in my department. This is a generative AI platform which enables users to create custom designs and also to apply them to physical goods through a very simple interface. But actually, the larger story here is about giving creators of all levels access to professional grade tools. Platforms like this one, platforms like Self-Tail, often have three core features. First, they use natural language-based design tools that convert ideas into visuals. Second, they use product catalogs, broad product catalogs, apparel, accessories, and digital assets. And third, they also use instant 3D mockups for previewing designs before proceeding to the production. And these features, these key functionalities, allow users to experiment freely without needing design or coding skills. Let's take a quick look at how Self-Tail brings your ideas to life through this intuitive AI-driven workflow. It all starts with a simple interaction. The system asks you a few natural language questions. There is no need for technical knowledge. You just describe what you want in your own words, and based on your answers, Self-Tail suggests suitable product types from clothing to accessories and beyond. And once you selected your product, the AI generates a custom design based on your input and instantly applies it to a 3D model. You can rotate, you can zoom, you can inspect your final creation in real time and to see how it will look before it is ever printed. And this seamless process continues creativity with precision, allowing anyone to get from idea to product in just a few clicks. With this platform, you are not limited to just one way of creating. For example, you can simply type a description, like, for example, a cat smiling for a selfie, and instantly generate a unique image. But actually, we don't stop there. If you already have an image you love, you like, you can upload it and apply a variety of artistic styles, everything from maybe Van Gogh to anime or surrealism. And this means that you are able to transform a simple photo into something that is unique, into something that fits your personal style. So what is the future? As we look ahead, we see the rise of a fully integrated creative ecosystem where AI tools connect seamlessly from idea to execution. Imagine starting with a design concept on a generative platform. That design flows into AI-powered marketing tools like Veo or Sora, which can instantly create videos, lifestyle images, and other promotional materials, which are tailored to your audience. From there, you can use analytic tools and powered models like ChatGPT or Gemini, which can create feedback to monitor engagement and even suggest improvements based on the current trends. And actually, this circle creates a continuous feedback loop where design, promotion, and strategy, business strategy, are all connected. It's not just about individual tools anymore. It's about how these tools can work together to support design, analysis, strategy, marketing, and in general to support creators in every step of the design process. Fashion and cosmetics are leading adopters of this technology. In fashion, generative AI helps design custom pieces tailored to individual style. In cosmetics, these technologies power personalized skincare and makeup recommendations, which are often integrated into e-commerce platforms.
Wind up within 5 minutes. Extremely sorry. Within 5 minutes, try to wind up, Professor Zerogiannis.
Thank you very much. I
Okay,
will
okay.
conclude my presentation by presenting the challenges. So while the potential of generative AI is enormous, it comes with some real challenges that we cannot ignore. First, there is the issue of authenticity. AI becomes capable of producing hyper-realistic content. However, we have the risk of misinformation and deepfakes, and this raises question about how we can verify that what is real and what it is not. Secondly, we have ownership and liability. These issues remain unclear. Who holds the rights to an AI generative design? What happens when those creations closely ensemble existing works? Privacy is another key concern. Many AI systems are trained on massive data sets, sometimes without full transparency. Finally, user adoption is very critical, and user adoption depends on trust. If people feel overwhelmed or skeptical, they will not engage with these environments. Thus, building intuitive, transparent, and ethical tools is essential, not just for legal compliance, but in order to keep the trust and earn the interest of everyday users. In this transparency, in this slide, there are some foundational works in the relevant literature, which present the background, the technical background of all these technologies. And let me finish my presentation by concluding my speech. This revolution is grounded in serious research, from text to 3D models to diffusion systems, and new academic and industry work is advancing, and these tools are very rapidly change. And it is important to understand that generative AI is not just a trend, it's a part of a broader evolution in how we can interact with technology and design. Ladies and gentlemen, thank you again. Thank you for your time and for your attention. I will be happy to take any questions.
I will request our audience any questions. If it will be there, then Professor is eager to answer. Any quick questions from audience side? Okay. Thank you so much, Professor Gerogenius, for your inspiring and thought-provoking keynote. Your reflections on generative AI have opened up new dimensions for us to think about, from content creations and self-test to the challenges and ethical considerations that must guide this rapidly evolving field. You have shown us how we are entering a new era of product customizations, where AI supports the entire product life cycle, empowering creativity at every stage. I was especially struck by your powerful idea of AI democratizing designer, making creativity and innovations accessible to everyone, regardless of the background. And when you connected this with the proud legacy of Athens, Greece, as the birthplace of democracy, it beautifully illustrated how the principles of inclusivity and shared opportunity remain just as vital in today's digital society as they were in ancient times. We are also grateful for the way you share the beauty and achievements of the University of Thessaly, Greece. It not only highlights academic excellence, but also reminds us of the importance of building bridges across borders, cultures, and disciplines to advance research and innovations together. On behalf of everyone here, I extend our sincere thanks to you, Professor, for your invaluable insights. Your words will surely spark fresh ideas, meaningful discussions, and future collaborations throughout this conference. Thank you so much, Professor Gerogiannis. Thank you so much.
Thank you very much, Professor Samit, for your very warm words. It is a great pleasure for me to participate in your conference. And
I would request
I
Professor
congratulate you for the excellent organization. And I will be very happy to have again the opportunity next time to participate,
Sure.
this time on site, in order also to visit your beautiful country and have the opportunity
We are
to
anxiously waiting for
interact
you.
with you
Sure.
physically. Thank you very
So
much.
I would request Professor Jerojanis, because there is another eminent speaker today for another 10 to 20 minutes. If you can wait and hear him also, it will be so pleasure for me. Dear audience, let us introduce Professor Nilanjan De. He is very famous personality in India. I know, young, enthusiastic. He is from Department of CSC, Techno International, New Town, Kolkata, India. Nilanjan De is a senior member of IEEE, received the BTech and MTech in Information Technology from West Bengal Board of Technical University, and PhD degree in Electronics and Telecommunication Engineering from Jadavpur University, Kolkata, India in 2005 and 2015 respectively. Currently, he is the professor with Techno International New Town, Kolkata, and a visiting fellow of the University of Reading, United Kingdom. He has authored over a huge 380 research articles in peer-reviewed journals and international conferences, and 40 authored books. His research interests include medical imaging and machine learning. Moreover, he actively participates in programs and organizing committees for prestigious international conferences, including World Conference on Smart Trains in System Security and Sustainability, World S4, International Congress on Information and Communication Technology, ICT, International Conference on Information and Communication Technology for Sustainable Development, ICT 4SD, etc. He is also the editor-in-chief of International Journal of Ambient Computing and Intelligence, associate editor of IEEE Transactions on Technology and Society, and series co-editors of Springer, tracked in Nature, Inspired Computing and Data, Intensive Research from Springer Nature, and Advances in Ubiquitous Sensing Applications for Healthcare from Elsevier, etc. Furthermore, he was an editorial board member of Complex and Intelligent Systems Springer, Applied Soft Computing Elsevier, and he is an editorial board member of IEEE Data Description, International Journal of Information Technology, Springer, International Journal of Information and Decision Science, etc. He is also the fellow of IETE and member of IE and ISOC, etc. It is really feeling a proud moment for me to welcome Professor Nilanjan De to start his keynote address. I think Professor Day is not audible to the online audience. ना ना और किसी बच्चे को पूछिए ना जो ऑनलाइन बैठा है। हमें ही सुनाई नहीं दे रहा है, सबको सुनाई दे रहा है। और किसी बच्चे को पूछिए फोन करके जो ऑनलाइन है।
Sir, it is not audible, sir.
It is not audible to all the online audiences.
Is it fine
Yes,
now?
sir, online audience.
Is it audible? Yes. Okay. Hello. Hello.
Now it is somewhat audible, but you have to.
Hello. Hello. Hello.
Yeah, it is audible now. But two devices are simultaneously working there, so that's why some echoes are there.
नहीं इसको म्यूट कर
So
दी तो सब
mute other devices. Other devices are also it has to be muted from single device. You start speaking.
उसको अनम्यूट उसको म्यूट कर दो। Is it fine now?
Yeah, absolutely fine.
Okay, so I'm actually starting from the very beginning because there is always a chaos. So the topic is how real the real enough. So it's a high time we need to think about whenever we talk about synthetic data, how much real the actual reality and real are. So pi computation is a very primitive computation. So if we try to find out the exact value of pi, 3.1415, it's an infinite numbers. Now, some Swedish scientists in very recent time in 2021, they reported 62.8 trillion decimal points. And that too takes 108 days, 9 hours. So 62.8 trillion digits, it's a huge number. It's so-called big data. They prove the power of supercomputer. They prove the power of so-called you can say big data, what actually in reality it is. Now, interestingly, amongst those 62.8 trillion digits or decimals, how many numbers of decimals we required in reality? In reality, we require 10 decimal points to find out the circumference of an Earth. Now, 32 decimal points we required for the Milky Galaxy, the circumference computation. Now, for finding out the Planck's length, that means what is the observable universe, what is this, how many numbers of digits we required, that required 65 decimal points. So that means 62.79 trillion digits, which we generated, but they don't have any scientific value. So we are majorly generating data. They might have any scientific value. So we need to revisit the question, how bigger is, we used to say always that bigger is better. Now it's a high time to think that do it really mean that if I talk about bigger, it's always better? Now, there is another data type which is called the dark data. So dark data is typically a kind of data. 90% of the overall data space is dark data. Dark data is a massive amount of information which never opened. Open means nobody actually used, nobody actually analyzed, nobody anyhow, anywhere that used that particular data. Say, for example, phone or recommendation system, or maybe anywhere you captured some data, or maybe customer review, customer complaints, they never opened up. So 90% of the data, overall data, is dark data because nobody opened, nobody actually thought about this, that is the data is a good data or it's a bad data. So the second question is, are they good data or are they bad data? We don't know. So whenever we are talking about big data, first thing is there is a majority of the data which don't have any scientific value. Second thing is majority of the data, dark data, which never opened up. We don't know it's a good data or bad data. So the third question, how digital waste actually polluting the planet? That is basically, it's nothing but data pollution. So whenever we are talking about big size data, majorly we are talking about data pollution, because in reality, scientific value of data, we actually need data or maybe good data is very, very less. Now, talking about any machine learning algorithm, the intrinsic nature of machine learning algorithm is very much depends and sensitive to the data which you are feeding for the training purpose. Now, if you are feeding garbage, output will be garbage. So always the training data need to be consistent. The data needs to be very much observable, consistent to the target point. So that's why we need always good data. Now, whenever the data comes, we don't know it's a non-scientific data or it's a dark data or it's a so-called bad data. Now, we should have a mechanism that will clean the data. So the very first thing of machine learning algorithm is the cleanness of the data needs to be there. So what do you mean by the cleanness? Now, basically, if the data is not clean, it negatively impacted the whole predictive model. Now, whenever there is a negatively impact in the prediction model, the output which you are getting is basically a sloppy kind of result. So that's why we need to remove the bad data or clean the bad data. Now, what is bad data? Bad data can be inconsistent data, it can be erroneous data, it can be missing data, it can be redundant data, it can be garbage value, it can be contextual errors. So all these are bad data. But till now, there is no one single algorithm, one particular algorithm, which can clean every type of badness of the data. Because for all badness, there is some algorithm, but there is still no single algorithm. If you feed the data, it will clean the data. Now, there is an interesting quotation, all good data are look alike, but bad data are bad in their own way. So all good boy there is a similarities, all looks like similar. But once we talk about bad guys, their badness is different. So for the data also, good data are good data. They are almost alike. But bad data, the badness is different. So we need to find out what is the badness is there in the data. That is the very first thing of any machine learning model design. So how much data we required for machine learning algorithm? That is the fourth question. So whenever we talk about machine learning algorithm, there is a common question, how much data I need to feed. But interestingly, there is no heuristic strategy. There is no meta heuristic strategy which tells you that this much amount of your data you require for machine learning algorithm. We need more and more data, and more data means that is there is a high chance the data will be garbage. So we need to pass through a proper training mechanism, and before that we need to process through a proper cleaning strategy. So cleaning strategy is important, otherwise all this dark data and non-scientific data will enter. Now talking about deep learning is nothing but a memorization technique. Now whenever we talk about deep learning, the basic missing part of deep learning is the absence of the relationship of underlying variables. It failed to identify that there is a relation in between the data. So that's why we need to train our system with all different variable data. So it's not about big data, it's all about variable data. So if you're taking a photo, 1,000 photo of Taj Mahal from one angle, that doesn't make any sense in machine learning. You have to take from all 360-degree, you have to take all the photo. Then only if the variability is there, then only machine learning model will be robust. So that's why the major limitation of any neural network framework, that is the underlying relationship in between the variable, which is a missing component, which you need to overcome. That's why we need a lot of different aspects of variability. So that's why it's all about not data. It's all about big, clean and variable data. So that's why the fifth question, how big the data should be, clean data. Now this is one part. So if we have lot of data, if we have big size data, we always need to go through a proper cleaning mechanism. But there are a lot of other challenges. One challenge is there are many cases where the availability of the data is very less. Say for example, you have 50 data of a patient or maybe 10 data for a particular say application. Now, how can you come up with some small size data processing for machine learning? The major problem is if you have a small size data, the variance will be very high. It will revolve around. And there is a chance of overfitting. Unseen data, it will not give you a proper result. There is a chance of say, outlier cases, which is very dangerous. So amongst 10 data, if one outlier, even in 10,000 data, one outlier, the first case is very vulnerable. So the interesting part is not how to deal with the big data. Rather, in machine learning, another interesting challenge is how to deal with small size data. So if your size, the data is very small, if the disease is chronic, application, the data availability is very less, how can you cope up with? So machine learning should not only deal about big size data, even though there is a data hungriness, intensive nature, but still it should be always into the other side of the coin, that is basically the small size data processing. Now, once we talk about data, today everybody talks about this, that data is the fuel of this AI, in this generation. Now, interestingly, only fortunate few who actually not trapped with all this kind of non-scientific data. So therefore, always many of the people who are actually trying to come up with their own fuel, they can create their own data, which is expensive, but sometimes it's very effective. Yes, I am one of them who create their own data. So how to create this data? So now 60% of the overall data space is now synthetic data. So synthetic data is not actual data. In real data, we are trying to replicate that data, which is a time consuming process, costly, sometimes impossible. But what is the advantage of synthetic data? Once you have synthetic data, there is no privacy concern, there is no legal or ethical issue, there is no copyright. So if you have a Mona Lisa and which is a synthetic generated, so you can you can play with that Mona Lisa without touching the original Mona Lisa. So if you have some medical data which is very much chronic disease, and that data, if you're not actual data, you can take a replica of that by generating synthetic data. And that's why generative AI actually evolved. So once we talk about all these GPT and all these things, but before that there was GAN. So generative AI is not actually a new thing. So almost 60% of overall data is nowadays generative data, or maybe you can say synthetic data. Now there is a question, it's a big question, that in future, synthetic data might be the future of machine learning algorithm. So if you have small size data, in future, we need to create our own data, synthetic data, which will actually save or help for the machine learning design. Next, please. So Today, if you talk about 2023, 24, this time, if you go through this graph, you will see still now the real data and synthetic data is almost crossed. And in future, in 2020, 30, it is predicted that synthetic data will be almost in the top, I mean, very high from this, peak in a position from the real data, which actually indicates that how fast this synthetic data and the world is moving towards that synthetic data. The reason, there are many reasons. One reason is this legal ethical issue. If you are trying to overcome by this way, then it's always easy to go through that kind of model design. Next. Okay. So now the question is, how can poorly generated synthetic data and lack of diversity in synthetic data actually amplify the biasness? So if you are actually trying to create synthetic data from a major data space where the availability of the data is very less, the variability is very less, automatically, whenever you are creating the synthetic data, you will see the biasness will come into the model. And that is inherent biasness. Day by day, it is increasing. So whenever we are creating synthetic data, we should create from variable data. If you are not creating from variable data, biasness will be a big issue for this. And second thing is, how come this low quality synthetic data actually mislead the results? So model behavior. So if you are dealing with say very low quality synthetic data, basically which is generation strategy, or maybe from based on which data you are creating the synthetic data, if there is a flaws, fundamental flaws, you will ultimately see that it will mislead the whole model. So data quality and the inherent biasness is a big issue for synthetic data generation. Next. Okay, so now once we talk about, everybody's now talking about this XAI or explainable model design. Now, once we deal with synthetic data and 60% data is machine learning model is trained with synthetic data. Now, what about the XAI on synthetic data? Now, that need to be understood and that need to be trained properly, because XAI, as it is evolving, it's growing, the explainability of the model design. If you are dealing with XAI, the major challenging part is XAI always explain the model, the behavior of the model. The main limitation of XAI is it's never talk about the data. So whatever the data we are feeding, XAI is not bother about this. XAI is only bother about the model. So that is the major limitation of any explainable AI model design. Now, if you are dealing with synthetic data, which is biased data, which is compromised data, low quality data, automatically the explainability of the model design will be not so good. So the trust issue and the reliability issue, which is actually we try to overcome by this XAI model design, which is a kind of in stake if you are dealing with such kind of model design. So that is the one thing. And lastly, the complexity, we need to understand the terminology called machine unlearning. People always talk about machine learning. There is another side which is called unlearning strategy. What is unlearning? Say, for example, I shared my data today, and after 10 years down the line, the whole model is getting trained and it is giving good result. After 10 years, I am saying, I need to revoke my data. I need to reclaim my data. I not want to share my data, which is very common nowadays because of these all data privacy protection law. People are scaring to share their data, or even they share their data, they are trying to roll it back. Now, without going for retraining, without investing any more money, can I come up with a model design which will give you same result or almost same result without not compromising with the result set, just by deleting or omitting some certain data, which is called forgetting data or forgetting machine learning or so-called machine unlearning strategy. As the number of synthetic data is increasing day by day, gradually the other thing is also increasing. People are started reclaiming their own data. So if world is getting filled with synthetic data, people will try to reclaim the data. Only saving part will be machine unlearning strategy. So that can be a future direction of research of many people also. There are very few algorithms are there, 2-3 standard algorithms for machine unlearning, but it's a huge area where the student can work, which is called the unlearning strategy development. How can you come up with unlearning mechanism? And lastly, next please. Lastly, the interesting part is we don't have still any acceptable metrics to find out the success of machine unlearning. How good your unlearning strategy is, there is still a lacuna, there is a still gap There is no such matrix. For machine learning, there are a lot of matrices are there, confusion matrix and ROC curve indicator to tell you how good your algorithms are. But on learning strategy, till now, there is no acceptable matrix. So some synthetic data, is it confident data? Again, no, it's not a confident data. There is an uncertainty, there is biasness, there is against the real data, but still now the flow is everyone chasing to generate more and more synthetic data. So we need to stop somewhere, just like me now I'm stopping, but before that we need to rethink and revisit that, okay, we should go and back and think that how real is real enough, so that sometime it will not chase me and tell me whatever the data I'm dealing with, I don't know, is it a real data or it's a fake data or it's a synthetic data. Next. The last one. So before concluding, this is, I think everybody's encountered these things. I am a robot. So this is a day where we are encountering, I need to prove machine that I am not a robot. So one day the day will come, my own data will revolve around in the globe, and I need to prove that it is my own data. And I need to prove that the data is a real data. So that day should not come. The artist say, maybe actually it's my own painting and somebody is saying it's not real. I know it's real. So we are not far away from that day. Thank you very much. Next. So I'm not taking any query. I'm directly going to the last slide. Thank you very much to everyone.
Thank you very much, Professor Nilanjan De. The
Thank
topic
you.
is very interesting for all of us. You have enlightened, that thought-provoking keynote. You have
Thank you,
given
sir.
us a comprehensive picture of both the power and challenges of artificial intelligence. Your discussion on dark data, nearly 90% of which is unstructured, reminded
Yeah.
of the vast untapped potential in the digital world, while
True.
also making us aware of how unchecked data growth is itself contributing to environmental concerns. Your points on data hungriness, the huge requirement for clean data, and the strategies needed to clean dark data were truly insightful. Equally valuable were your reflections on deep learning, memorization techniques, small data problems, and the need to create our own data to ensure reliability and sustainability. I especially appreciated your balanced perspective on synthetic data. While it represents an exciting future for machine learning, you reminded all of us of the adverse effect of low quality synthetic data and the risk it possesses to model performances and trustworthiness. Another crucial takeaway was your emphasis on explainable AI, XAI methods, what you have told, which are essentially for understanding the behavior of AI models and ensuring transparency. And your reflections on the complexities of machine unlearning highlighted a frontier challenge, how to effectively remove learned information without compromising overall system integrity. On behalf of all of us, I extend my deepest thanks to you, Professor, for delivering such a rich, enhanced, and forward-looking keynote. Your insights will surely inspire further dialogue, research, and innovations among everyone here.
Thank you,
Especially
sir.
those
Thank you
who-
very much. Thank you, sir.
Okay, so if there will be any questions or any queries from the audience side, you can interact directly with professors.
Hello. Thank you, Professor Sambit Kumar Parida sir. Sparing your valuable time and chairing the session wonderfully. And we are also very grateful to you also and two keynote speakers today, Vasil C. Groganians and Professor Nilanjan De. And both lectures are ultimately very important and informative. And both lectures are on cutting edge technology, Nilanjan De said about the real data and machine learnings. It is a wonderful lectures and Varsal sir also given one lecture on artificial intelligence. Both lecture hopefully benefit to the scholars and researchers. So we are very grateful to both of you. And thank you very much, sir, for spending your valuable time and sharing the session.
Thank you. Thank you, sir.
Now we are moving in our next session paper presentations. Now I welcome Dr. Ved Prakash sir.
Bye all.
Bye. Nice presentation.
Ved Prakash sir, are you there? And Ritu ma'am, Dr. Ritu Bhargava ma'am.
A very good evening to one and all. Thank you so much, sir, for inviting me. Thank you so much.
Dr. Ritu Bhargava is Associate Professor at Department of Computer Science, Sophia Girls, Ajmer. She has PhD in Computer Science from Hemchandra Gujarat University, Gujarat, India. She has more than 15 years of active research and teaching experience. She has delivered a series of talk and lectures at reputed University of India. She is a life member of CSI, member of ASEAN and IEEE. She has several books on national and international publisher and more than 30 prominent research paper in international journals, and contributed as a organizing chair in more than 15 national and international conferences. Her area of research including data mining, GIS, spatial data management system, machine learning, 3D computer graphics, computer vision, e-learning, and ad hoc network. Her work of face recognition and fingerprint recognition has been cited in many reputed research work. Welcome, ma'am, for this chairing the session. Now, I call the first scholar for the sessions. Well, sir, welcome. Wait, sir. Now I am the first caller. Paper ID AI01 Anubhav Arya. Paper title Fingerprinting the Invisible. Detecting malicious encrypted traffic using TLS 1.3 flow metadata. Anubhav Arya, are you there?
Good afternoon, everyone. So my name is Sameer Khan, and I am from MSc from MIT University, Jaipur. So today I am presenting our research paper on detecting malicious encryption traffic using TLS 1.3 flow metadata. The project is titled Fingerprinting and Invisible because our the main goal to analyze encrypt traffic, something is usually hidden without breaking encryption. This work was carried out me, Samit Khan, and my colleague Anubhav Arya at AIIT, MIT University, Rajasthan. So, introduction. TLS, Transport Layer Security 1.3, has become the standard for secure communication. While it provides excellent privacy, it is also blind security tools because payload inspection is no longer possible. Attackers are now abuse TLS tunneling to hide malware, botnets, and even large-scale data exfiltration. And the problem statement. The traditional intrusion detection IDS system were designed to inspect traffic payloads, but with TLS payloads are encrypted. Signature-based method simply cannot read them, and even attacker exploit HTTPS, VPNs, and TLS session to bypass detection. This raises is a crucial challenge. How do we detect malicious activity without actually decrypting the traffic? The motivation is clear. There has been significant rise in the ransomware, phishing, and malware distribution over the encryptions channel, cyber criminal exploitation, TLS, and 1.3. Over to you, my friend Anubhav Arya.
So signature-based methods don't work in this environment. Decrypting traffic at scale is not practical, which we all know. It breaks privacy. So it consumes heavy computational resources and simply doesn't scale for ISPs and enterprises. That's why we needed a middle ground or intermediary, and that's where metadata and behavioral patterns come into play. Our approach is very simple and it is some kind of powerful also. First, we will extract metadata like packet size, in packet interval timing, and handshake information. Then we will apply JA3 and J3S TLS fingerprinting to generate unique identifiers for clients and servers. After that, we will train machine learning models like XGBoost random forest to classify whether a flow is benign or malicious. J3 and J3S fingerprinting. What it is? J3 generates a fingerprint of the client's TLS handshake, while J3S does the same for the server. It generates fingerprint of server message. These values, when hashed, gives us some unique identifiers. We also know that malware families often use distinct TLS configurations, so their fingerprints can also be recognized from this technique. For example, the MD5 fingerprint shown here is associated with suspicious traffic. The datasets. We have used two well-known public datasets. First one is ISCX VPN, non-VPN data, and the other one is USTC TFC 2016. Together, we use this dataset. This provide a mix of benign and malicious encrypted flows. They are balanced, publicly available. Everyone can access it and widely used in security research. That's why we have taken these datasets for our research paper. And it also makes our results comparable to other studies. Let's go to feature extraction. We extracted three main types of features. The first one is flow features, such as packet length distribution and burstiness. The second one is timing features, like inter-packet arrival times. And third one is TLS handshake parameters, such as cipher suits and extensions. If we combine them, they will create a strong behavioral fingerprint for each flow. So what machine learning models we have used is written here. First one is random forest, which works well with structured data. It is very good for tabular data and it is robust also. The second model is XGBoost, which is known for high accuracy and handling imbalanced data sets. Third one is neural networks, which can compare complex and nonlinear patterns. We compared their performance to find the best performance in between them. We pre-processed the data sets and the models and splitted them into training and testing sets. Each traffic flow was then classified as benign and malicious. We also used cross-validation to ensure our results are statistically reliable. We have simulated the model in a controlled environment. We set up controlled environments with both benign and malicious flows. This allowed us to test how our models behave in real-time detection scenarios. This is a experimental setup. These tools we have used are written here. That is Zeek, Wireshark, and Python. Our results are good. We achieved detection accuracy of 90% and a little bit more than 90%. The system consistently detected malicious flows with high reliability. It proves that metadata combined with machine learning can effectively identify threats in encrypted traffic. So we can also say that encrypted traffic if the traffic is encrypted, it doesn't mean that we can't see anything. If any payload is going through that, we can also detect it. Let's see the advantages. Our approach has two main advantages. First one is it is privacy preserving. Since we are not decrypting the traffic is still encrypted. It is also scalable and suitable even for large networks like enterprises and ISPs. In addition to this, I'd like to add one more point, that method works across multiple datasets and show its generalizability. What are the use cases? The system has strong applications and it has shown very good output. Enterprises can also use it to protect employees from encrypted traffic where malwares can easily went into the network. ISPs can deploy it and to detect botnets or large-scale malware attacks. Maybe it might possible that government agencies can also secure some infrastructures without violating privacy laws like GDPR. What are the limitations of my model? Let's see. Of course, there are some limitations in my model on which we will work very soon. Our experiments are conducted in controlled conditions and pre-existed data sets. Real-world networks are very far diverse or very different from data sets. So validation in the field is very essential. Also, there is a risk of false positives in my model. We will work on it soon. If the data set is real and it might possible that my model will give some false positives, so it is a limitation. It might possible that my model will not give such kind of 90% accuracy because of highly diverse traffic. So what is the future work of my model? What will we do in future? We will collect and use some real world traffic data sets. Okay, sir. We will collect some real world traffic data sets and strengthen our model. We will make sure that it will also work against adversarial attacks. We will deploy the system in enterprise networks or we will try for it. We can also integrate some adversarial training to resist evasion attacks, which can be implemented by attackers. So, what is the conclusion of our research paper or my works or my team works? To conclude, encrypted traffic does not make detection impossible. If we will combine metadata analysis, TLS fingerprinting, and machine learning technology, we can effectively identify malicious encrypted traffic. Our results are really promising on the data sets, and our next step is to bring this system into real world environments. So this is the references, and thank you, sir. It's in.
Recommend any question from your side?
Question batana.
Okay, Anubhav. And one I request from my side to each scholars, you have only 7 to 8 minutes to present your paper. During your presentation, you have to just conclude about your outputs, what your achievements. Don't go to introduction and other theories. We have a very short time. And within this time, you have conclude your paper, 7 to 8 minutes, about your contributions, basically. Right?
Yes, sir.
Okay. Now I call next scholar paper ID AI 08. Karan Yogesh bhai. पेपर टाइटल है ESP 82866 वाईफाई सिक्योरिटी सिस्टम.
आवाज नहीं आ रहा है. Sorry, sir, your voice is not coming to me.
My voice is not audible.
Hello.
Hello.
Oh, yes, sir. Yes, sir. Yes, sir. Yes, sir. You are audible.
Now I am audible.
Yes, sir, you are audible.
Yes, sir, you are audible. Someone else PPT sharing.
Please next one, 08 ID, and conclude your presentation within time period. 7 to 8 minutes.
Sir, we are not able to sharing our screen.
Okay, now we are sharing. Am I audible, sir?
Yes, yes, you are more than.
Okay, sir. Good afternoon, everyone. My name
Yes,
is
screen is visible.
Okay, sir. My name is Karan Kunt, and today I'm going to present my research paper PPT with my co-partner Smith Karodia. Today topic is ESP266 Wi-Fi network security system. The objective of my work is a design to a low-cost security solution for detecting unauthorized access in wireless network. Wireless networks are an essential part of every organization today, but they're also among the most common target for cyber attackers. Honeypot is a default system designed to lure attacker and record their activity. In this project, I used the ESP266 microcontroller to create a default Wi-Fi network.
Skip introduction. Okay. And current any technical issue? Can I call next caller? Now I call next caller, paper ID 11. Madhu Kiran. Paper title is novel intrusion detection model for detecting known and innovative cyber attack. Yes, Madhu, please share your screen.
Yes, sir. Yes, sir. I will be sharing.
Yeah. Start your presentation.
Good afternoon, everyone. Myself, Ruben George Thomas, and Madhu Kiran. We are from the Department of AIIT, Amity University, Rajasthan. So today we will be presenting our research on novel intrusion detection model for detecting known and innovative cyber attacks. This works focus on how CNN or convolutional neural networks can improve intrusion detection beyond the limitations of traditional. In today's digital era, as cloud computing, IoT, and large-scale data systems continue to expand, the attack surface for cyber criminals is growing rapidly. Traditional intrusion detection systems rely heavily on signatures, which makes them effective only against known threats. However, they struggle with zero-day and evolving attacks. Our proposed solution is a CNN-based intrusion detection system that can analyze complex traffic patterns in real time. This enables it to detect not only known attacks like SYN-flood attacks, low risk or group, but also innovative and previously unseen attacks. The methodology. We started with KDD's datasets, which contain both normal and malicious traffic. Then pre-processing steps were taken, such as cleaning, normalization, and feature selection were applied to extract meaningful parameters like TCP UDP segments, IP flows, and ICMP statistics. The dataset was split into training and testing subsets, and a CNN architecture was designed with convolutional pooling and dense layers for classification. The model was trained and evaluated using standard metrics such as accuracy, precision, recall, and F1 score. After achieving strong results, the trained model was serialized and deployed in a Flask-based web application, enabling real-time detection through a simple user interface. Moving to our key findings. Our findings showed that the CNN model significantly outperformed the traditional IDS approaches. It not only detected known attacks, but as well as capable of recognizing zero-day variations. The model achieved high accuracy with low false positives and was efficient with just limited sets of selected features. Another key strength was the scalability. Since our architecture is modular, the system can be retrained with new data sets or extended to recognize additional attack categories. Lastly, by integrating the model into Flask-based app, the system became user-friendly, allowing even non-experts to use it effectively. Now I give the chance to my co-author Madhukiran to continue the presentation.
These are the Now I will be telling about challenges. We have done this on pre-collected data sets and not on a real-time traffic. And also we compared with attack with normal traffic imbalance. And also training a CNN model will be very high since we need heavy resources, etc. And manual input, real-time limitation include manual input of features required. And also adversarial evasion, risk of crafted input fooling deep learning models also. Then future scope of this project is now we have done with the pre-collected data sets. In the future, we integrate with the integration of Scapy or Whiteshare for live traffic analysis. And also we automated the alerts to the person who is look after in that by using giving notification via email, SMS, or dashboard notification for immediate response. Then periodic retraining includes update with new data sets for zero-day resilience. So zero-day effect is the most common now compared to based on the signature based. And also visual dashboards includes advanced analytic for monitoring and decision support, and automated response, proactive defense mechanism for large-scale deployment. And conclusion, which includes CNN-based ideas overcome limitation of traditional signature-based methods. Since signature-based methods compare with the previous data, whereas CNN-based ideas detect a zero-day vulnerability, which will be useful for the companies so that they can detect the new attacks as well, and successfully detected known attacks as well as some of the novel attacks, which include SYN-flood, UDP flood, low risk, HTTP flood, ICMP echo, slow post, and brute force. Achieved high accuracy and reduced false positive, integrated into Flask web application, which is a user-friendly and practical, and adaptive to evolved threats, proactive cyber security defense, provides a scalable foundation of real-time monitoring, automated response. In this, I will be showing two examples. Like we have provided some of the data sets include ucache packets, outcache packets, TCP segments, TCP in segment, out segment, TCP which open ports, UDP datagrams, everything. by giving all the around 9 to 10 data, we will be analyzing which type of attack it is. I am showing here ICMP echo. By analyzing these data sets, we are getting the ICMP echo. Next one is by analyzing this, we are getting the brute force attack. And these are the references. Thank you.
Excuse me. Madhukiran, can I ask you one question?
Yes, ma'am. Yes, ma'am.
Yeah. So first of all, I appreciate yours and Ruben's work. It's quite interesting. The question which comes in my mind is, like you said, you are there is a 0-day resilience, and another thing you said, it reduces the false positives, right?
Yes, ma'am. Yes, ma'am.
So just I wanted to know that like you are using 0-day attacks, and which when how will you generalize the unseen patterns during the attacks without generating excessive false positive? Here you are saying you have reduced the false positive, but how you are going to do it? Because when you combine it by means when you look to the patterns, okay, and you are using 0-day, then how you are going to reduce the false positive? That's my concern.
Ma'am, actually, we got the pre-collected data sets, and we are working on to detect the 0-day attacks, ma'am. Like 0-day attacks
Okay.
in the we are working on that one, ma'am. Like we got only pre-collected data. By analyzing that pre-collected data, we came to know these are the attacks. Like we compare with the signature-based attacks, ma'am. In the next upcoming days, we are analyzing for 0-day attacks. Like we are planning to create one environment, like normal hosting an environment, and also we are planning to attack using some other devices. We will be trying to attack that machine, so that we will be collecting some of the data, and we are analyzing that data patterns and confirming whether it is based on attacks which are already there or new attacks. And we are working on that one, ma'am.
So have you ever tried, have you checked the confusion matrix? Okay, like really it is giving reduce the false positives. Have you checked it?
We have checked for a little bit, ma'am, but we did not get proper this one,
Okay.
like proper information about that one. We are working on that one.
So it's a nice paper both of you have worked on. Just this was my concern. Please go through with it, and congratulations for your paper.
Thank you so much, ma'am.
Now I go
Hello, ma'am.
next caller.
Hello, sir. I'm Karan Phunt. Can I again share my PPT because of technical issue I cannot able to share?
Karan, wait. One point, Professor Gaurav Skolkar. Whenever you start your presentation, if in case more than one scholar presents the same paper, so kindly tell us your name before start the presentation. If more than one scholar in a given paper, right?
Okay, sir.
Yes, for every student. Yes, start presentation.
Okay, sir. Thank you. Good afternoon, everyone. My name is Karan Phunt, and with my partner Smith Kathodia, we're going to present my PhD paper, ESP266 based Wi-Fi unencrypted security system. The objective of my work is a design to low-cost security solution for detecting unauthorized access in wireless network. Talking about introduction, wireless network are essential part of every organization today, but they're also among the most common target for cybersecurity attacker. Honeypot is a decoy system to design the attacker and record the activity. In this project, I used the ESP260 microcontroller to create a honeypot Wi-Fi network. This network attracts unauthorized users, monitors their action, and provide real-time alert to the administrator. Problem arises because many organizations operate a Wi-Fi network with the weak or outdated security measures, such as networks are vulnerable to unauthorized access, brute force attempt, and able to attack. Existing professional security solutions are either expensive or too complex for small organizations. Therefore, there is a need for a portable, affordable, and efficient system that can detect suspicious Wi-Fi activities and provide administration with the immediate alert. Objective of my project is the primary objective of project is a build a honeypot Wi-Fi system using ESP260 that can detect unauthorized device in real time. Additionally, objective is including tracking repeated connection attempt by same device, identify able to attack, and sending instant alert administrator. The project also includes a local admin panel where all connected devices and logs can be viewed. Scope of this project is mainly focused on small-scale environments such as educational institutions, small businesses, and a research lab, where deploying expensive enterprise security system is not feasible. While the system does not prevent attack, it provides a quick detection and reporting, which help to administrator take timely action. In the future, the system can be expanded with advanced features such as the cloud dashboard or machine learning for intrusion detection. Talking about literature review, previous research highlighting the importance of honeypots in cybersecurity, as they help study attacker behavior and provide a real-world threat intelligence. ESP8260 is widely recognized as a low-cost microcontroller with a Wi-Fi capability. Often used in IoT projects, while many studies have focused on traditional or wired honeypots, there are very few low-cost wireless honeypot implementation. This project fills that gap by offering a portable and affordable Wi-Fi honeypot solution. Hardware requirement used in project is minimal. The core component is a ESP8260 node MCU board, which provide a Wi-Fi compatibility. USB cable and power source, such as a laptop or power bank, are used to power the device. Finally, laptop or smartphone is required to access the final admin panel and the monitor activities. This makes the setup extremely cost-effective and portable. The software environment requirements for the project included the Arduino IDE for the programming the ESP260. The SPFFS the file system is used for storing the logs locally. Real-time alerts are enabled using the Telegram bot API, and candy token are used for silent alerting. The ESP8260 also runs a lightweight web server, a host and admin panel at the local host, which administrator can use to monitor and manage devices. From a system architecture, the system works in the following way. The ESP260 create a Wi-Fi access point with the normal password, making it appear like a genuine network. When a device connected MAC address is checked against a whitelist. Whitelist means it's the listed of authorized MAC address and devices. If it is unauthorized, the system logs are attempt and send alert. The system also detects evil twin networks and repeated connection attempts, storing all the data locally for further analysis. Key feature of this project is a real-time detection of unauthorized devices, tracking repeated connection attempts from the same MAC address, evil twin detection, and instant alerting via Telegram and Candy token. Additionally, the system provides an admin panel for live monitoring and log management. The admin panel hosted on ESP8260 at one local admin allow administrator to view connected device along with the authorized status. It provides options to research and filter device, add or remove MAC address from the whitelist and view logs with timestamp. The panel is designed to be simple and responsive and accessible from the both mobile and desktop devices. From the next slide, my co-partner will explain. Smith Katode will explain.
Hello everyone. My name is Smith Patrodia, and from here I'll take over. So talking about alert mechanism, we have two alert mechanisms. First one is the Telegram. So in Telegram bot, we connected it with our ESP8266 so that we can get the instant notifications. And the second one is a canary token, with the silent breach detection. So we also get notifications via email. So alert trigger on three alert provide three alert messages. First one is a unauthorized device connection. Second one is a repeated MAC connection attempts, and third one is a evil twin detection. So talking about evil twin detection,
The evil twin detection is the system continuously scan for nearby Wi-Fi networks with the same SSID. SSID is we can say SSID is a Wi-Fi name. If a duplicate Wi-Fi name is found with a different MAC address, it will generate the alert. It will flag as an evil twin. The alert is sent on the admin, enabling them to take precautionary measures. It will send alert via a Telegram bot or an email. So a second flag is a repeated MAC tracker. So each device connecting to the honeypot is monitored by its MAC address. So the MAC address comes twice or thrice. If a device connected there 3 or more times within a 5 minutes, so the alert will trigger. Talking about data logging, log store using SPIFFS. SPIFF is a mechanism in a ESP8266. So it will extract and store the data and logs. It stores MAC address, time span, and event type or authorized status. And it will also useful for forensic analysis. So here I showed some result of our alert system when after alert detected. So first one is a detection of unauthorized device via serial monitor. Second one is a notification come through Telegram bot. So in next slide, we also described 3 more screenshots which showing our alert system. So first one is a detection of evil twin attack. Second one is a Telegram alert of evil twin attack. Third one is a repeated unauthorized MAC address. This MAC address comes twice. That's why our honeypot detected it and send us notification. So here is a canary alert in Gmail. So we implemented canary token in our honeypot so that it will detect and generate the alert via Gmail. This is our admin panel. You can see here connected devices, and in the second image, here is a alert settings, Telegram and Canary, and the third one is a unauthorized device list, and fourth one is a white list where we can authorize the person, so they cannot be detected by honey. Now, what is the advantages? Our honeypot is a low cost and portable, easy to deploy and manage, and also provide real-time monitoring. So conclusion, the system is effective for detecting Wi-Fi intrusion attacks, and for future enhancement, AIML, we can implement AIML based intrusion classifications. We can automatically block a MAC address via AI and ML, or we can also go for cloud-based logging dashboards. So references, that's all. Thank you.
Yeah, thank you, Karan and Smith. The objective of your paper is quite clear, but the suggestion from my side is you have used ESP8266, right? And
Yes, ma'am.
you have used it. So, in my point of view, I think now the alternative and newer version has already came, like ESP32, right?
Yes, yes.
Here, your whatever IoT sensors you are using, whatever this processor you are using, you must have studied in this also, there is a single core processor used in ESP8266, right? But in
Yes,
32,
yes.
it is dual core. So there
Yes.
will be a restriction. You can only use the basic IoT sensors in your paper, right? And advanced IoT sensors you will not be able to use. So it is better to switch. Otherwise, the object is very clear. Okay, just you need to upgrade your technology so that most benefit you can get from out of your
Yes,
paper.
yes, ma'am. We
That's a
are
suggestion.
implementing. Yes, ma'am. Yes, ma'am. We are implementing AIML in ESP32 for next our project.
So that would be much better, na? So
Yes,
that
yes,
you can expand your research thing.
yes, 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 ma'am.
Okay, thank you both of you. So
Thank you,
there's
ma'am.
one request to all the participants to kindly conclude their paper within the time limit, which is 5 to 8 minutes, 5 to 7 minutes. I think your moderate sir has also briefed you about the timing. So it is, please, restrict yourself to this time period. Otherwise, other presenters will not be able to present their paper well. Okay.
I would like
So Yudvi, you can call the next participant.
Instead of I would like AI paper writing states with paper techniques and behavior based a comparative study of cybersecurity. Ritu ma'am, am I audible?
Yeah, your voice is not clear. I think it's a network issue. It is echoing also. So you can proceed.
Okay.
Thank you.
Hello. Hello.
Yes, you can proceed with your presentation, Deepshika.
Okay, ma'am. Okay, ma'am. Good afternoon, everyone. My name is Deepshika Singh, and along with my co-author Charul Kadle, I am delighted to present our research on signature-based versus behavioral-based threat detection, a comparative study. Our work focuses on comparing two major approaches to threat detection: signature-based methods, which are efficient against known malwares, and behavioral-based methods, which are critical for detecting zero-day and evolving threats. We further explore how hybrid detection models can offer a more resilient defense mechanism for the future. Through this presentation, we aim to provide insights into these trends and limitations of these approaches, real-world case studies, and a proposed hybrid framework that align with modern cybersecurity needs. Starting with signature-based detection. Signature-based detection is one of the oldest and most widely used methods in cybersecurity. It works by identifying malicious code through unique identifiers such as hashes, byte sequences, or known patterns. When an incoming file or process matches a stored signature, it is flagged as malicious. Talking about its strength, they are speed, resource efficiency, and accuracy for known threats, where low rates of false positives when dealing with previously cataloged malwares are found. But it also has some weaknesses, which are zero-day blind spots, where they are ineffective against new and unknown malware, polymorphic malware, and constant update requirement. Signature-based methods remain effective for handling known threats, but fall short in dynamic and evolving threat landscapes. Next is behavioral-based detection. It is similar to signature-based detection, but a little more advanced, where it focuses on monitoring systems and user activities in real time by using ML and AI. It identifies anomalies that deviate from normal behavior. For example, an unexpected file encryption operation may signal ransomware activity. Its strengths are unknown threat detection, broad coverage where it detects insider threats, command to control communication, C2C, and privilege escalation. Behavior-based detection also has some weaknesses like false positives, resource consumption, and continuous tuning, where it requires ongoing calibration and AI/ML model updates. And while behavioral-based detection is powerful, it also demands sophisticated infrastructure and skilled analysts. Now, I would like to call upon my co-author Charul to explain further.
Thank you, Deepshika. Good afternoon, everyone. Continuing the
From the introduction, I will now discuss signature-based versus behavioral-based threat detection. As Deepshika said, highlighted the key points about the cybersecurity challenges. I will now focus on the two real-world case studies. The first is WannaCry ransomware in 2017, where signature-based detection missed the unknown exploit, but behavior-based detection caught abnormal encryption activity. The second is SolarWind supply chain attack in 2020, where signature-based methods were ineffective, but behavior-based detection flagged suspicious lateral movement. This clearly shows the difference between the two approaches. Moving ahead, my part of the presentation will cover a comparative analysis. Signature-based detection is fast, accurate for known threats, and light on resources, but weak against zero-day attack. Behavioral-based detection is strong for unknown threats and zero-day, but it requires more resources and generates more false positives. So both approaches have trade-off. Next, let's look at the tools available. Signature-based tool includes Snort and Suricata. Behavioral-based tools includes OSEX and Splunk, and hybrid platform that are like Snort, Suricata, and Zig combine the best both of the world. To address the limitations of each method, hybrid detection models are used. They combine signature and behavioral methods to improve detection accuracy, reduce false positive, and provide layer security. Key features include real-time signature, matching context-aware behavioral analytical, and integration with SIEM, XDR, and cloud security system. Our proposed framework built on this idea. It focuses on scalable design, capable of handling large datasets across distributed systems. Prioritize alerts, minimize alert fatigue by ranking threats based on the severity. Automated response, enable rapid containment and remediations. MITRE attacks alignment ensures global standardization and strategic defense. To conclude, both methods are complementary. Signature-based is effective for known threats, while behavioral-based is crucial for zero-day and evolving threats. The future lies in hybrid models supported by adaptive AI-driven solutions for resilience against every changing attacks. Thank you.
Thank you, Charul and Deepshika. Nice comparison work you have put in your paper. So, just one question from my side to both of you. Could you please tell me which method you like the most, signature-based or behavior?
Ma'am, for starters, I would like to say behavioral based would be a better approach because it also, detects zero-day exploits. But for a bigger picture and for a larger organization, hybrid models are the best because you get the best of both things.
Okay. Thank you, Deepshika. Congratulations. Best wishes.
Thank you so much, ma'am. Thank you, ma'am.
Now I would like to call upon paper ID AIAIA27 Soni Tanish Kumar on paper title AI Techniques in Automating Digital Forensic Investigations.
Hello, am I audible?
Yeah,
Am I
you're
audible? Good afternoon, everyone. Today I will presenting on AI technique in automated digital forensic investigation. Myself, Sachin Kumar Gujar, and my fellow mate Tanish Kumar Soni. The focus of this presentation is how artificial intelligence is transforming the way investigators collect, analyze, and present digital evidence. Abstract. Traditional forensic methods are slow, manual, and not suitable for today's massive digital data. Imagine an investigator going through terabyte of log and image manual. It's simply impossible to keep up. AI introduced automation, anomaly detection, and smart analyzing. In this presenting, I will discuss different AI techniques, their benefit, challenging, and future direction in the field of digital forensics. Introduction. Digital forensics is the science of gathering, preserving, and analyzing electronic evidence in a legal and admissible way. With the rise of cybercrimes like ransomware, phishing, insider threats, and fraud, forensic capabilities have become critical. However, traditional approaches like manual logs review and file system analysis are too time consuming and prone the human error. AI, on the other hand, can process huge volumes of data quickly and uncover hidden patterns. This makes AI a game changer in modern forensic investigation. Background related work. Digital forensic spans multiple domains: computer forensic, network forensic, cloud forensic, and mobile forensic. The key challenge faced by investigators are first, extremely large volume of data and data is stored across different platforms and anti-forensic techniques like encryption and the heavy manual workload. Researchers have applied AI in many ways, like machine learning for anomaly detection and malware classification, NLP for phishing detection and text analysis, computer vision for facial recognition and deepfake detection, and knowledge graphs for linking suspects, devices, and events. And now, the hand over my fellow mates, Tanis Kumar Soni.
Good afternoon, everyone. My name is Tanish Srinivasan. Today, we are going to explain machine learning plays major role in forensics. Supervised learning used for malware and artifact classification. Unspecified, unsupervised learning is used for clustering and anomaly detection in logs. Application includes behavior analyzing and detection malware without replaying and signatures. This may it possible to catch zero-day attacks. NLP. NLP is extremely valuable analyzing unstructured text data such as emails, chats, and logs. It helps entirely extremely like timestamps, IP addresses, usernames, and has case fraud, keywords mining in email, and communication recorders. Computer vision provides by deep learning is used to analyze image and videos. Convolution neural network or CNNS helps recognize phase and objectives in configured media. Deepfake detection is author critical application. OCR or optional character recognition converts scanned document into a searchable text, speeding up investigation. This follows investigation to works with photos, videos, and even scanned files in the smarter way. Deep learning models like RNNs and transformers can reconstruct timelines of events and detect insider threats. They are also very effective in anomaly detection for unknown or hidden patterns. Knowledge graph, of the other hand, connect suspicious device, location, and activities. They can create investigation maps like link for fragmented data, for example, connection a cloud file to a USB inserting event. This helps investigate see this bigger picture instead of isolated bit of evidence. Benefits of AI in forensics. The benefit of AI forensics are sustainable speed. AI is much faster than the manual analyzing. It can handle terabytes of data effortlessly. AI reduce the human error. AI can anticipate threats before they occur. It frees investigation to focus on high priority evidence instead of representative tasks. Of course, AI is not perfect. There are serious challenges we must acknowledge. AI will
Tanish, can you
evolve.
please
Yes, ma'am.
can you please come to
Ma'am, what, ma'am?
can you please come to the conclusion? The time is exceeding.
Yeah, ma'am. Deep learning module often act black box with no transparency. Further detection of conclusion. AI is not here to replace forensic investigation. Instead, it empowers them by automating threats work, enabling them to focus on complex decision making. By continuing AI with legal and ethical safeguards, digital forensic can become a faster, more accurate, and more reliable. Thank you, ma'am. These are the references. Thank you.
Okay, thank you, Tanish and Sachin, I think. सचिन एंड तनिष मुझे जी एक बात जानिए आपसे कि आप डिजिटल फॉरेंसिक की बात कर रहे हो तो डिजिटल फॉरेंसिक तो बहुत ही हेट्रोजेनस डेटा यूज करता है isn't it?
अभी देखता हूँ मैं देखता हूँ
So how you are going to handle it, the heterogeneous data? है ना, डिजिटल फॉरेंसिक में तो कितना अलग अलग डेटा आता है, इमेज है, कॉल रिकॉर्ड हो रहा है ना, एमएमएस इमेजेस हैं, ऑडियो रिकॉर्डिंग्स हैं, और भी कॉल आपके कॉल लॉग हिस्ट्रीज हैं, ओएस का भी होता है। तो ऐसा हेट्रोजीनस डेटा आप कैसे अपने उसमें हैंडल करोगे? इस जो आपने भी अपना पेपर बनाने की कोशिश कर रहे हो उसमें ये डेटा सेट ऐसा उसमें हैंडल कैसे करोगे और एआई को कैसे उसमें इनकॉर्पोरेट करके मतलब ऐसा डेटा कैसे हैंडल होगा?
डेटा अपन डेटा सेट्स के थ्रू और उनका जो एक अपना जो मेथडोलॉजी है मशीन लर्निंग के थ्रू इन सबको कंबाइन करके बना सकते हैं जिससे कि अपना हैंडल हो सके डेटा।
ओके, थैंक यू।
वेलकम मैम।
Before the participants start their next presentation, I would like to announce that please maintain the decorum. We have only 45 minutes left and around 7 presentations are remaining. So please maintain the decorum. Please maintain the timing constraint and 5 to 6 minutes maximum. Please take, and you have to discuss about what your contribution is, and it is then supported by results and discussion. So please maintain the decorum, all the participants.
Now I would like to call upon paper ID AIAIA28 Sudhanshu Nigam for paper title Detecting Fake News and Social Media Threats Using AI.
Am I audible? Am I audible to you, ma'am?
Yeah, you're audible.
Okay, thank you, ma'am. So, very good afternoon to everyone. My name is Indaraj Gujar. Along with my colleague Sudhanshu Nigam, are very excited to be here today at this conference. The topic which we are going to present today is detecting fake news and social media threats using artificial intelligence and how it can solve real-world problems. So the introduction is, we chose this topic because fake news is not just an online problem, but it affects politics, society, and even more, which we are going to discuss in this presentation. Fake news is not just a false information. It spreads faster than the truth, especially the platforms like Facebook, Twitter, and WhatsApp. The misinformation can be influence politics, create a social division, and cause a financial scam, and even lead to violence and unrest also. As an artificial intelligence can help over here because it can analyze huge amount of online content quickly and detect pattern human might mismatch. The The problem statement overcomes that how we can manually check, we can't check manually every piece of news, as because it take time consuming and also impossible of large volume of content upload every second. Cyber criminals can take also advantage of this by creating fake accounts, bots, and automated system to spread misinformation on massive scale. Another issue is that the fake news is often designed to look like very convincing, make it harder for ordinary user to tell what's the difference between that. The objective, the first objective is to detect fake news in real time so that misinformation can be stopped before going viral. The second objective is to identify online threats such as phishing links, scams, and propaganda campaigns. The another main aim is to improve accuracy of detection by using advanced artificial intelligence and natural language processing techniques. In short, the objective is to about speed, accuracy, and prevention and awareness. Now, I would like to call my colleague Sudhanshu Nikam to take over from this presentation.
So thank you. And next topic is methodology. So firstly, we collect the data for the new data sets from social media feeds. Next is pre-processing, tokenization, stop, word removal, text cleaning. Third step is model training, ML, DL models like Better, LSTM, Bayes, etc. Then we go to classification, like which is the fake news and which is the real news. Then fifth step is threat detection. Alert the system for the phishing or the false post. Next, which technologies and tools we are using. For programming, we are using Python and we are using libraries like Spec, PyTorch, etc. Dataset like Fake News Net, etc. The proposed framework of our AI model is data pre-processing via AI model, then classification of real or fake news, then threat alert. Next, what are the results of our AI model is accuracy of 70 to 80%, like about that nearby approximately, or the current we are using, the tool we are using is BERT, that his accuracy is 92%. Our confusion matrix is very much good as we expected. Then what are the application of this project? The social media monitoring like Twitter, Facebook, Instagram, etc. Next, election and political campaign protection, preventing cyber propaganda and misinformation, financial investment and prevention. Future works. So real-time API integration with Twitter and Facebook, and combination of AI, blockchain for content verification, AI for deep web. And now I would like to call Indaraj for the conclusion.
Thank you, Sudhanshu. So the conclusion is that although AI-driven is a system and using widely, and it can detect remains evolving field, requiring and strong artificial intelligence model, and it can be a global collaboration also. Thank you. These are the references over here.
Thank you, Sudhanshu, for your paper. आपका ये जो वर्क है वो मल्टी मॉडल डीप फेक्स को भी डिटेक्ट कर सकता है?
Yes, ma'am.
मल्टी मॉडल कर सकता है?
Yes, ma'am.
मैम
एक्चुअली उसमें जो अलग अलग जितने भी प्लेटफॉर्म्स है उनके डेटा सेट्स को कंबाइन करने की अभी प्रोसेस कर रहे हैं. एक्चुअली हम अभी उसमें 75% हम एक्यूरेसी अभी ला चुके हैं, बट हमारा टारगेट है कि हम 90 to 92% उसको एक्यूरेट कर सके जिससे कोई इश्यू नहीं आए.
Wow, then it's going to be really good paper.
या मैम.
तो इसको एक्सटेंड करिएगा, ये बहुत अच्छा बनेगा आपका.
यस मैम. थैंक यू मैम.
Congratulations. Thank you.
थैंक यू मैम.
Now I would like to call upon paper ID AIAIA32 Tuptevar Bhakti Naresh with paper title Classical Cryptography versus Quantum Cryptography under Post-Quantum Threat Models.
Hello everyone. My name is Manisha Chaudhary and today I and Bhakti Tuptevar are going to present. the topic classical versus quantum cryptography. Today, most cryptography like RSA and ECC depends on solving tough math problems, but quantum computers can solve them much faster with algorithms like SHORs. That means our current methods might not be safe in the future, so we need new quantum safe techniques to secure communication. Now let's quickly look at what classical cryptography actually is. Classical cryptography basically means the methods we already use like RSA, ECC, and Diffie-Hellman. These are based on hard math problems which normal computers can't solve easily. They are fast, efficient, and used everywhere. The problem is once quantum computers get stronger, they can break these methods. So what's different in quantum cryptography? Let's see. Quantum cryptography works on the principles of quantum mechanics. The most famous one is QKD, that is quantum key distribution. It has two main ideas. First is you can't copy quantum states. Second is if someone tries to spy, it disturbs the state. So you know someone is there. So basically if a hacker tries to eavesdrop or interrupt, it can caught immediately. But how do we prepare for the time when quantum computers are fully here? That's where post-quantum threat models come in. Post-quantum threat models simply mean how safe will cryptography be once quantum computers are common. Quantum algorithms like Shor's and Grover's can break RSA, ECC, and many others. So researchers are planning how strong will the system remain? Can we implement new methods easily? What's the best way to shift from classical to quantum safe methods? So one good option that I would suggest is a hybrid cryptography. That is a mix of classical, post-quantum, and quantum. Now let's compare classical and quantum cryptography side by side. Here's a quick comparison. In terms of security, quantum cryptography wins. In terms of speed and cost, classical is better. That is classical cryptography is better. Classical also scales globally and is easy to use. Quantum is still in experimental stages, so both have their strengths and weaknesses. Now I would like to hand over to Bhakti. With this comparison done, Bhakti will now explain the challenges of quantum cryptography.
Good afternoon, everyone. As Manisha now explained the comparative part of classical and quantum cryptography, as Manisha now explained the comparative of quantum and classical cryptography, I would like to proceed further. So even though quantum cryptography is super secure, it's not very practical yet. It needs to special infrastructure like fiber optics and quantum repeaters. It's very sensitive to noise and works only for limited distance. Plus it's costly to complicated to use. That's why it's not everywhere right now. So what's the solution to this? That's where hybrid approaches is coming. Instead of fully shifting to quantum, researchers suggest hybrid approaches. This means combining post-quantum method like lattice-based or code-based cryptography with classical cryptography for efficiency. And for every high security area, we can integrate QKD. This way, mitigation happens step by step without breaking current systems. Now let's look at the main findings from our study. The key points are quantum cryptography is theoretical, unbreakable, but classical methods are still more practical right now. The best strategy is start adopting post-quantum cryptography as standards, use QKD only where really needed, and slowly move towards fully quantum system cryptography. These findings are backed by well-known research which we have listed in our reference. And these are the reference we use like Shor, Bennett and Brassard, Eckert, NIST PQC standards and some recent research. They gave us the knowledge to prepare this presentation. And finally, let's wrap up with our conclusion. To conclude, the future cryptography is definitely quantum secure, but for now, both classical and quantum need to work together in hybrid system. Thank you for listening and giving precious time to us. Thank you.
Ritu ma'am, would you like to ask any questions? I would like to call upon AIAIA 33 paper ID with paper title Prompt Injection Attack, Stimulation and Detection Tools, Vaghasia Kuldeep.
Good afternoon, sir, ma'am. Am I audible?
I would like you all to conclude your presentation on time because the time is getting over.
Am I audible, ma'am?
Yes, you're audible.
Good afternoon, everyone. I'm Prayag Jerikun. This is Victory. It's my today professor. We are from MIT Institute of Assessment. Today we will present our research on induction estimation and detection tools. It is with an information set packaging, then cover text types, methodology, detection tool, result, discussions, and final. We our take those. So introductions. So large language model by facilitating software development, education, customer service, and content production. Large language model, ChatGPT and has rapidly changed a number of industries, but there are the scenario security risk associated with the broad adoption. Prompt injection text in which in the- the prompt injection attacks in which users create input that overriding model intended behavior can manipulate events because they are made to process natural language input. Means this creates a large language GPT are reshaping industries from education to customer service, but they face up to security risks from injection. These are malicious prompt that override intended behavior, causing data leaks or misuse. This will stimulate this context from shared reading and thought detection. So, previously, anyone are in the chatbots, healthcare, and various many systems that talking that it bypass safeguard and create privacy and trust issues. With prompt injections, so malicious input to manipulate using response of previous processing everything of models. So there are two main types like direct injection and indirect injection. They can directly use control instructions like ignore rules and so efforts. It's like direct injection. Indirect injection is malicious instructions are hidden in child links or effects are harder to detect. So what challenges we face? So these effects are hard to check because malicious from similar to normal and because we act for it. Operations, some instructions carries over approximately for instructions. This makes pure detections very challenging. So what related calls have means we use like research and prompt injection last studies highlights vulnerabilities and LLMs usually focus on organizing and managing tools for analysis, map for analyzer variants of prompt injection attacks against research, industries and design defense or many other tools like pencil for elucidate uh, like so in research methodology, we built a PHP-based ranking dashboard linked to an API API. We launched every student and created 25 malicious prompts, including command.
Can you please conclude your presentation?
Okay. So, video forward, sir. They will continue.
Good afternoon, ma'am. I'm Kuldeep. In conclusion, prompt injection checks compromise the integrity of LLMs and pose a real risk. While exist, while existing tools show promise none are completely foolproof against attacks. Approach that includes sanitization, multi-agent verification, and continuous monitoring is required. Future AI system must embed strong and adaptive defense to maintain trust and ensure safety. There are some reference. Thank you.
Okay, thank you. Now I'd like to call upon paper ID AIAIA 3634 Vidis Deepak Kumar Solanki with paper title A Zero-Day Attack Detection in the Financial Sector Using Generative Adversarial Network.
Hello. Good evening, everyone. I am Vidhi Solanki and with me is Kushal Sharma. Today we are presenting our research on zero-day attack detection in the financial sector using generative adversarial network. Introduction. So during COVID-19, the financial sector became highly digital. People shifted to online banking, UPI, mobile wallets because physical access was limited. This increasing digital transaction but also made the sector a targeted for cyber attacks. Zero-day attacks are particularly dangerous because they are new and unknown. This situation makes cybersecurity in finance extremely important. My research focused on using generative adversarial network to detect these unknown attacks while protecting sensitive data. We will go for literature review. As we all know, traditional IDS tool like SNOS, Shurikata rely on signature-based anonymous bits, which makes them ineffective against zero-day attack. Generative adversarial network, a type of deep learning model, use generated and discrimination in adversarial training, which detect anomalies even with very few label samples. Many studies show uh, GAIN works well in cybersecurity, but few focus on zero-day attack in financial sector, which is the gap my research paper address. Next slide, please. The main gap is that traditional IDS fail against unknown attacks. Label data from zero-day attack is very limited. High false positive reduced trust and real-time detection is dynamic in financial system become more challenging. Research object, please. In our objective era, built a robust GAIN-based detection system for zero-day attack in finance, improving detection compares to a traditional IDS, reduce false positive so that they can trust to sectors and with required to provide framework to involve with new cyber threats. I will hold to Kushal Sharma.
Hello everyone. My name is Kushal Sharma. I am from the cybersecurity background. So basically, my topic is the material of the methods. How the GAN network is work. Like in the how we use the GAN network in the financial sectors. Let's take one example. Like one example, one organization want to the GAN network in their organization. Firstly, we are the cybersecurity experts. We take the their data, then we check that data, and then we make the one GAN network using that data, train that data, and the in the GAN network we use the generator and discriminator. Generator generator make the fake data that look like a real data, and then discriminator try to find that fake data, and that way the GAN network will be trained. That how the our GAN network will work. Um, the result is like a very good after we apply the GAN network. The zero-day attack reduced by the 98% from the organizations. The false positive rates are decreased by the very good, and the successful detect anomalies based traffic, traditional traffic, and the, improve the detection system from the 5% to 11%. For the future scope, we run the we use the more data, more big data sets to train a good our system, and the integrated model, like we use the real time threat detection system uh, for the good results, and we use like enhanced detection accuracy. uh, Thank you so much.
Thank you. Now I would like to call upon paper ID AIAIA40 Jayesh Sharma for explainable AI for student performance prediction. Jayesh, are you ready or should I give chance to another one? Before Jayesh, I would like to call upon AIAIA paper ID 36 Vinay Verma with paper title AI powered web presenting pen testing.
Hello everyone, my name is Pranav Sanjay Ghandale and my co-author Vinay Verma is going to introduce about the AI-based web penetration testing. So basically it uses machine learning models or large languages model to automate the discovery, exploitation and validation of vulnerabilities in web applications. Just unlike traditional scanners, we have PubSuite or Nikto, which rely on uh, rule-based signature uh, that think strategically like human pen tester. It also reduces some false positive by validating vulnerabilities automation. So basically, why AI for web pen testing? Because as we done manually, manual testing is very slow. It involves very quickly AI. Traditional scanners miss context-aware flows. Basically, it scans hundreds of endpoints can be tested in parallel. So how AI sees its target. So basically, as the first step, as the reckonance, it understands the target, basically such as the web headers, cookies, and JavaScript to responsive framework. And second step is adaptive learning. As we all know, the AI is very adaptive. It lists the static payloads. It can add this payload encoding, URL encoding, Unicode, double encoded, and based on the observed patterns. So third step is the behavioral analysis. As the machine learning models detect anomalies, time delays, unusual status codes, AI compares these behaviors with unknown vulnerability patterns such as SQL and SSRF. The fourth step is the decision making. So as AI prioritizes which attack vendor is most promisingly instead of brute forcing everything. So the methodology of AI-powered pen testing. So basically, as I discussed before, the data collection reconnaissance, the websites like Nikto does, but AI extracts context, forms, hidden, hidden palm. Second step is the attack surface mapping, payload generation and mutation. Fourth step is response analysis and anomaly detection. The fifth step is exploit chain automation, and the last is report and risk prioritization. The next slide is going to represent my partner Vinay Verma.
Hello, good afternoon, everyone. Am I audible? So, thank you, Pranav, for explanation and for the introduction. Now, I would like to explain about the vampire testing tools. So, as guys you know, Expo is currently the latest web testing tool that is, being on the leaderboard of HackerOne that found so many vulnerabilities of OWASP top 10. Expo is a autonomous AI-driven pen testing platform designed to discover, validate, and exploit vulnerabilities. It is built by Og Dimol, creator of GitHub Copilot. The second one is Deep Exploit. Deep Exploit is a AI-driven pen test tool developed in Japan. The key features are it uses reinforcement learning to automate exploit selection. It scans, find vulnerability, and launch exploit without human intervention. It can do all the processes on their own. Third one is the AI argument pen testing assistant like Pentest GPT, which help payload crafting and expert chaining. Fourth one is the dark trace cyber AI, which is the expertise level tool, which use anomaly based ideas and threat detection using ML. The next slide is our research work in which how AI work, using in how AI work in pen testing. The first one is adapting payload generation using NLP. It means we have to create a good level of payload that can understand the flow of website, how website render, how backend give response when a user interact with the user. It AI uh, can AI can do all the work that
I would
can.
like you to conclude your presentation now.
Yes, ma'am. So AI can helpful in attack chaining just by finding a simple level of vulnerability to remote code execution. For example, if you find an XSS that you can you steal cookies, which you can log in as an admin with session management. It can also find bugs between hidden links and handle complex architectures, just like JWT, and that humans can't do without. And at the last, I would like to conclude: AI does not replace the researcher; it amplifies the capabilities and find connections they might overlook. It reduces manual effort and, unlike hidden vectors, improve research and deepen insights. These are the references, ma'am, and thank you.
Thank you. Now I would like to call upon paper ID AIAIA 40 Jayesh Sharma with paper title Explainable AI for Student Performance Prediction. Jayesh, are you there?
तो नहीं हाँ, ना मेरे पास दो थे तो इसके बाद एक और है इसके बाद 10 मिनट
Can you please start? Jayesh, we have limited time. Can you please start? You are not audible. Jayesh, you're not audible. So I would like Jayesh and Chubby Bagel to present tomorrow as we have limited time. So thank you so much, everyone. Thank you so much, everyone. You all can leave the meeting and we'll continue tomorrow. Thank you.